Good morning. Today I'll share with you one of the ongoing work that I'm working on in relation to technology. So we talk about how generative job design shapes the skill impact of technological change. So what I bring with me is this constructivist view to the idea of technological change, that it's not definite, it's not deterministic. So we'll talk about how the idea of the way that the job is designed will shape how it impacts our jobs. Oh, I'm sorry, I didn't introduce myself. I'm Chia Ying from the Institute for Adult Learning in Singapore. So what we do is we look at how education, learning, the labor market changes, and technology is one of those topics that I'm personally interested in. Okay, so when we talk about the age of AI, especially in more recent years, it's the idea of the human age, of what remains for human labor in relation to technology. So when we think about technology, that's two perspectives. Traditionally, we talk about automation and displacement, but more recently, especially with more recent generative artificial intelligence technology, we think about what remains of augmentation of human capabilities through technology and the human age in bringing with that. So today we will investigate how job design mediate the impact of technological change on skills and job outcomes. And what I bring with me is a constructivist lens and a new micro-comparative perspective and evidence using the PIAAC data. So when we talk about studying the impact of technological change on work, there's two ways to think about it. More traditionally, it's this idea of what technology can do. It's a deterministic approach to it. We look at the impact of digital technologies and measured against what experts' technical assessments of the level of susceptibility of different occupations, jobs, or tasks to automation, or most recently, traditionally it's more automation. This comes with Frey and Osborne, but more recently I think we have there are papers from ILO and that talks about how particular tasks or occupations are allow itself more to augmentation, but this is really based on what is technologically possible. But I think what we actually think, my research team actually like to think about is that it's not just about technology, but how they are being used and implemented. The same technology can be used differently, even within the same occupation. So we look at how digital technologies are currently being adopted across contexts, across workplaces, paying attention to the context. So not just the content, but the context in which they are being used, alongside the implications for productivity, job redesign, and the evolving demands for skills. So this is the perspective that I'll take today. So then we bring it together with this idea of generative job design. So in the age of AI, when we talk about what remains of human capabilities, we want to think about how it fosters collaboration, problem solving, and more importantly, innovation, promote experimentation and new approaches to work, and to create the condition for continuous learning and adaptation as technology reshapes the future of work. So using the PIAAC data, we identify this idea of generative jobs. So I borrowed a lot of ideas from this paper on Storen, factors that promote innovativeness and being an innovative learner at work. So it's the idea of being innovative, being generative, creating new ideas, and how it relates to technology. So these are the dimensions that I picked up using what's available in the construct of PIAAC data. So collaboration, brokering, independence, discretion, complex problem solving, and learning at work. So of course, today we're using PIAAC data, a comparative and micro-level analysis with the comparative countries of Singapore, US, Finland, and Switzerland. So I think it's interesting, the country comparative, in the sense that it's, it's job design, but it's also how the way that institution arrangements affects the way that jobs are designed, how hierarchical levels, as well as interaction within the workplace. So the findings are interesting in the sense that they are not uniform across all contexts, and I think that's something that following this probably have to look further into. And we look at employees aged 25 to 65 who are not currently in further education. So there's two perspectives. First, the comparative perspective. So we look at the cross-country analysis of institutional differences of how technology adoption and job design interact to identify what patterns are shared across systems and where they diverge. And definitely it's the micro-level reporting to capture within occupation, within job variation in exposure to technological changes, and generative job features to support contextual analysis of how technology is embedded in everyday work practices. So to set up the investigation, first we look at technological change at work. So we measured it by looking at recent changes in machinery or information and communication technologies as reported by the job holder in the PIAC, in the respondent. So if they answered yes to recent changes in either machinery or ICT, then we take it as they experience some sort of technological change at work. And then we look at generative job design. So these are the dimensions that we picked up. When we run a factor, generally they load in one factor. So for parsimony over here, we just take the summation of it. So it's like a linear combination. But I think even if we do like a factor loading, the findings will not change too significantly. So we look at the interaction and the impact on outcomes. So there's skills and training, how it impacts the cognitive skills proficiency, cognitive task requirements, training participation, the job outcomes. So we look at wages, but because we don't actually have micro data for wages, we only have the Singapore data for that, so we'll look at that, how it impacts job satisfaction and firm level outcomes. So whether the firm is growing or declining. I think that's important because we look at replacement or the augmentation of technology in which impacts, or whether it results in more labor or less labor. So that's a perspective that this variable can shed light on. Okay, so let's just look at the patterns of exposure to technological change for a start. So when we look at the distribution by occupations, it's clear that it's not evenly distributed. So in Singapore, it's clearly very highly stratified and concentrated in skilled occupations. So mainly managers and professionals. And in fact, in Singapore, I think it's one of the, I didn't put it in, but the patterns are highly interesting in the sense that when it comes to skilled labor, the managers actually have a much higher exposure to technological change than even the professionals or the technicians. And this patterns is not actually similar in the other countries. So it's a very managerial-led kind of change economy. And in the lower skilled roles, especially even in the blue-collar roles, especially in the elementary occupations, the exposure to technology is very low. Even when it comes to the implementation of machinery, it's actually surprisingly low for blue-collar workers as well, especially in comparison to the other countries that we picked up here. And in the US, it's slightly uneven, but not as bad as what we see not as highly stratified as what we see in Singapore. But I think what's interesting is in Finland and Switzerland, the higher overall exposure and more evenly distributed across the workforce, including semi-skilled occupations. So we see that it's heavily implemented in occupations like sales and service, craftsmen and machine operators. So even with this, just the basic distribution, it's the group that actually then, so we'll look at the results, and the group that actually gets affected by technology, whether they benefit from it or not from it, it's clearly different in Singapore and like especially in the CMEs like Finland and Switzerland. So that's something that came up very strongly, and it's interesting. Okay, then we look at the distribution of job design in the different economies. So what's clear is that in Singapore, it's again highly stratified by the occupation. So like the blue-collar and elementary occupations don't benefit from a generative job design. So it's highly stratified and concentrated only in skilled occupations. Again, managers, more than professionals, with limited presence in the lower skilled role. And I think in particular, what we always see in our data, it's the very low proportion of job discretion. So that, I think it's, when it comes to looking at technology, it's one thing to look at the complexity of technology, but also how it affects things like task discretion. That's always something that it's interesting, and especially with a country like Singapore where job discretion is low. So US, job discretion is not so low, but it's also highly, not highly, but there's also some level of stratification. But in Finland and Switzerland, what we see is it's a more broad-based distribution of generative job design with high levels of discretion, especially in independence and collaboration across the occupation levels. So when we look at the impact of cognitive skills proficiency, what's very interesting, it's separately technological change and generative job design actually are negatively correlated to to the proficiency scores. Oh, okay. It should have been literacy, numeracy, and adaptive. Okay, I didn't change that. Okay, so it's the main effects are negative, but when it comes together, when technological change and generative job design are implemented together, then that's when the impact on skills proficiency is actually positive. But then in Finland, it's interesting because technological change, it's negative. But of course, then we have to talk about, we have to talk about the, of course, this is not causality, it's only the correlation. But I think this is still interesting. Okay, when we talk about the impact on cognitive task demand, it's positively correlated. But in Singapore, surprisingly, that the interaction, it's actually negatively correlated. So that's also interesting patterns. But in Finland, then it's not so much the technology, but the idea of job design that really motivates the cognitive task demand. So I think that's something that is interesting. And then in terms of training participation, it's positive for both technological change and generative job design, and we don't actually see any interaction effect. This is probably not surprising because with changes, with new technologies, with more, with this sort of innovative, generative type of job design, it's natural that it's correlated with the need for more training participation. The impact on wages, it's positive main effect, but there's no interaction effect. And interestingly, for job satisfaction, it's not the technological change, but how the work environment, the job design that actually motivates technological change. So it's a stronger determinant. And no main effect. Okay, but in Singapore, there's no main effect, but the coming together of the technological change and generative job design is positively correlated. Okay, and there's no job satisfaction effect in Finland. That's interesting as well. In terms of firm dynamics, technological change, we see that they have both positive and negative effects on the firm headcounts. And generative job design generally supports firms' headcounts growth in both Finland and Switzerland, but the interaction effect is not consistent. So what we actually then see is a non-homogeneous effect of technical change and job design across the countries. So I think quite clearly when I read the data, it's I can see the Singapore model and the Finland model. For the US and Switzerland, I thought the patterns were a bit like, I haven't really made sense of it. So if there's like, I welcome interpretation of it. But in Singapore, we have a very managerial-led and top-heavy kind of job and work organization. So it's unevenness in tech adoption. But what we then see is an integration of tech and job design that delivers benefit. But unfortunately, because it's only benefits the higher skilled occupation, and the bottom occupations are actually not do not benefit from it because they are not affected by technological change. They do not benefit from job design. So actually, then we need to think about how we can extend tech adoption and discretion to lower skilled jobs to enhance workforce capabilities more broadly. And this compares with the Finland model, which is a bit more participatory and integrative, more broadly distributed. So it comes to me that it's job design and not technological alone that can drive skills development in Finland, and it's broad-based discretion and collaborative work practices across roles that support workforce-wide capability building. So of course, then we talk about some limitations of the current evidence. Firstly, it's the causal interpretation, that this relies only on cross-sectional data, so we cannot draw robust causal inferences regarding the impact of technological change on skills. So we probably can only at best interpret them as associations rather than a definite effect. And probably when you think about beyond job design, there are also other individual resources or broader institutional arrangements that affects this. So while this analysis captures some of these aspects, the system may involve more complex interactions, so we have to think about what other maybe data or variables we can bring this into this model to look at it a bit more consistently. And lastly, this is the point that we have a last slide later on technological coverage. So the data largely predates more recent advances in generative AI. So the explosion of tools like ChatGPT is really within the last 2 or 3 years, which is slightly after the data collection period of cycle 2 of PIAAC. So it lacks that granularity to distinguish between different types of technologies and the applications in workplace context and the intensity of the adoption. So, and also because in the PIAAC instrument, we don't really capture like technologies like AI or like data analytics. So this is, share with you a little bit about one of the surveys that we run in Singapore to enhance how we can better capture this impact. So of course, types of technology that we want to capture, it's not just automation, or it's not just machinery or ICT technologies, but it could be things like computerized or automated equipment, AI or machine learning and data analytics. And probably we have to think about, when we run this survey again in the future, we have to think about what other technologies we can implement. The job quantity, So whether the number of people working the same type of work in an organization has increased or decreased. But when we analyzed this data, I thought there was a little bit of survivorship bias, because we interviewed the person who is at the job, who's still staying in the job. So when they talk about whether the job gain or job loss, they're more likely to report job gains, because those who lost that job probably would not be able to report this question. The job quality, so we have to look at the task complexity, whether it increased. If they were exposed to the technical change, we can think about whether the complexity increased or decreased, and the task discretion. So in Singapore, when we run these, we actually found that the direction of complexity and discretion actually moved in different directions, which is interesting, because traditionally when we conceptualize complexity and discretion, they are supposed to come together more strongly, but not in the case in Singapore in our data for certain occupation groups. And also then the risk of digital job redistribution with remote working and global team working. Okay, I'll skip this. And finally, okay, so in conclusion, when we talk about the impact of technological change and the human age in the age of AI, we want to put forth the message that technology alone does not determine the future of work. So job design can influence job and skills outcomes, and cross-country contrast highlights the role of institutions as well in shaping how technology and work design affect outcomes.